Continuous random variable. In a video before, we said that there are two types of random variable. One is discrete random variable. The other is continuous random variable. But what is continuous random variable? So we have learned about discrete random variable. So we have known discrete random variable. After knowing the difference between discrete random variable and continuous random variable, we would have a clear image of continuous random variable. So now let's learn about the difference between discrete random variable and continuous random variable. First, their values are different. The possible values of discrete random variable is countable and distinct. For example, if a discrete random variable, the possible values of it are number of students. The number of students are countable. For example, it can be 14, 15, and so on. And also, let's see another example of discrete random variable, the death rolls. Normally, the death rolls have 6 results. It's 1, 2, 3, 4 until 6. So it's countable and distinct. Even for a discrete random variable, its possible values are all the natural numbers. They are still countable. They are from 0, 1, 2, 3 until infinity. They are still countable. So we can check the number line. So the possible values of discrete random variables are discrete points on the number line. Are discrete points on the number line. They cannot be any number on the number line. And now let's see the values of continuous random variable. The values of continuous random variable are uncountable and continuous. So the possible values of a continuous random variable can be all the points on the number line, or they can be all the points in a range on the number line. For example, the height of people. The height of people can be any points in a range on the number line. Also, the time can be all the points in a range on the number line. And also the temperature. The temperature can be all the points in a range on the number line. This is the difference between the values of discrete random variables and continuous random variables. The second difference is the probability. The discrete random variables has probability mass function. The probability mass function is another name for the probability distribution. So the discrete random variables has the probability mass function, or it also can be called probability distribution. On the other hand, the continuous random variable has probability density function. They are different. We will talk about probability density function later. And the third difference between continuous random variable and discrete random variable is the outcome listing. So we can list all the probabilities of a discrete random variable. We can list them as the probability that the random variable equals x1, the probability that the random variable equals x2, and so on. But we cannot list the probabilities of a continuous random variable. For a continuous random variable, it's impossible to find the probability that a continuous random variable equals a value. For a continuous random variable, we can only find the probability that the random variable falls in a range. We can only find a probability like this. We cannot find a probability like this. So we cannot list all the probabilities of a continuous random variable. Now let's go on. We said that we can find a probability like this for a continuous random variable. The question is how to find this? How to find this? The method is integration. Integration. We integrate the probability density function to find the probability like this. For example, fx is the probability density function of the continuous random variable x. Then the probability that the continuous random variable x more than a and smaller than b equals the integration from a to b fx dx. If we see this on the coordinate system, it's like this. This is the graph of the probability density function of the continuous random variable x. Then we can find point A on the x-axis. This is point A. We can find point B on the x-axis. This is point B. Then we draw a vertical line at A. And we draw a vertical line at B. Then the area between the two vertical lines and x-axis and the graph of the probability density function fx. This area is just the probability that the random variable more than a and less than b. Just like the discrete random variable, the sum of all the probabilities of a discrete random variable equals 1. Similarly, the total probability over all cases of a continuous random variable also equals 1. So we have the probability that the continuous random variable more than the negative infinity and less than infinity. This equals 1. And this guy also equals the integration negative infinity fx dx. So the probability density function fx has a property here. that is, the integration of the probability density function from negative infinity to infinity equals 1. And also because it's impossible that a probability is less than 0. So the probability density function fx has another property, that is fx always more than or equals 0.